Okay, so here's a picture of the board we'll be using to drive the servos, the PCA 9685. Just a quick overview. We'll get into more details as we go, but on the left side is your input from your Arduino to make your data connections. Along the top here is 5-volt in to drive the actual servos. The DCC in here drives the chip on the board itself, but does not drive the servos. You want a separate power supply because of the current draw on the servos. The Arduino is not capable to handle that. So typically a 5-volt 2-amp is sufficient to drive multiple servos, unless you get in a really big configuration. Along the bottom are the connection headers for the servos themselves, 16 connections along here. And on the right side is if your daisy is chaining multiple of these boards together, you would make the continuation connections from here to the next board. It's a mirror of the pins on the left. They don't do anything different. It just allows you to connect multiple boards together, which would look something like this. We'll go into the connections a little bit different on ours because we're going to be using a Mega for the connections instead of a Uno, so the pin will be slightly different. But you've got your 5-volt and ground in and your data for the I2C connection there. The 5-volt in here drives the chip on the board itself. It does not drive the servos, and that's what this is for. This is your 5-volt power supply to drive the servos. Again, 2-amp would be sufficient to drive quite a few servos, but if you get a lot of servos together, you may even consider about that. Then on the right side is the daisy chain connections to go to the next board, and you just connect the pins from the right side of that one to the next board, and then from that board to the next one. You just continue it on. The one thing to note, the OE is the output enable pin, which we don't need. We're not going to be using. You could leave that disconnected and just connect the others. The V plus on the bottom is the 5-volt input to drive the servos, the actual power supply. And so that carries on that connection to each board, so you don't need to add multiple connections on the blue or green header pins. Just make the first one. So that's just a basic look at the layout of the boards. Now, if you do connect multiple boards together, you have to address them differently. They have to have different I2C addresses so they can communicate. You do that with the headers at the top of the board here, these pads. The board comes with all the pads open, not connected. That gives you an address of 0x40. In this picture, they put a little dab of solder on the first pin, which would give you an address of 0x41. If you leave that one open and do the next pin, it's 0x42. The progression from there changes. I'm not going to go into all the I2C addressing. If you need to get beyond that, you'll have to look that up, further research on the web to find out what you need. So anyway, if you're connecting multiple boards together, you do need to change the address on the board so that they can communicate with the Arduino. If it's just one board, you can disregard this. You'll get your 16 servos, and you don't need to worry about these pins. Okay, it's the time to define our turnouts in DCC EX. To do that, I'm going to assume that you have your basic command station installed to your Arduino, and you know how to use Arduino IDE and upload sketches to the Arduino. So I'm not going to go through that. So here I have Arduino IDE open with the command station open in it. To define our turnouts now, we need to create a new file as part of command station. If you look up across the top, you can see all these tabs that are all different files, all different parts of the command station. Well, we're going to create a new one of these tabs. You can do that by clicking on the down arrow and selecting New Tab, or you can use Control-Shift-N, but we'll select a new tab here. And down here at the bottom now, we need to name it. You can see this blank fill-in spot. So we're going to call it My Automation.h. Now look at the spelling. Oh, I spelled it wrong anyway. My Automation.h. Look at the spelling, look at the capitalization. The A on automation is uppercase, and it needs to be specifically this way so that the command station recognizes it under compile, and when it compiles this and uses it. So you can either just hit enter or click OK. We need to click enter. All right. So it's created this new file, and we can tell it because if you look at the top up here, you can see the myautomation.h. That tells you which tab that we're in. So here we could define our turnouts directly into the My Automation. The problem is if you start defining a bunch of turnouts, and then maybe you add some signals, maybe you add some sensors, maybe you add some scenery turnouts or scenery servos that do different functions, different things. This starts to get pretty cluttered. So you can break out each of those into another file. Kind of like the My Automation, we'll create one specifically for the turnouts. Once we create it, we have to include it into this automation file for it to actually be able to seen by DCC EX and for us to be able to control them. So we're going to include, which is done by pound and then lowercase include, then in parentheses, the file we want to include. In this case, my turnouts, and we're going to capitalize the T again, .h, close the parentheses. Now that will tell the command station when it compiles to use the file we're going to create called my turnouts into the automation. So now let's create that turnouts folder. So in this case, I'm going to go Control-Shift-N to create a new file. And then down at the bottom here, my turnouts.h. Click Enter, and it creates the new file. Again, we can see up at the top we're in the My Turnouts, and we've got a blank page. Now we'll define the turnouts in here. Okay, so to define our turnouts, once we're in here, we're going to use this command, all uppercase, servo underscore turnouts, and then the rest of this will actually define what we're looking for. The first part is the ID that you want to give to the turnouts. It's a number ID. You can pretty much use any number that you want. Some methods you could use would maybe be to define, let's say your staging area as turnouts 100 through 199. Maybe your main classification yard as 200 through 299. Maybe you've got a bunch of passing sidings along your route. You could define your passing siding as 300 through 399. It pretty much, you have to just kind of decide how you want to do that. Or you can do it a simple way as this. We're going to do it based on which pin is driving the servo. So I'm going to start off with this one as ID 100. Because next we need to tell it what pin on the PCA 9685 that the servo is connected to. DCC EX comes with pins 100 through 131 already set up. So you can use two PCA 9685s just built in without having to add new ones to the whole system. So it starts with pin 100. So that's why since we started with ID 100, we're actually going to start with pin 100. Next is the active angle. This is the angle of the servo arm when you hit the throw button. And just to start off with this one, we're going to start with angle 300. The inactive angle is the close angle. So we'll put, let's just say 450. The profile has to do with how fast you want the servo to move. And it goes from instant to slow in 4 different steps. So we'll show actually an example of all 4 of those. So we're going to do instant in this case. Next, as an option, is you can give it a description. So that's why it shows the bracket is that as an option. So we're going to take off this bracket. And the description is basically an alias. It's how it will be labeled in your Y throttle connected to your command station. So you could call it, if it's a passing siding, say it's north of town passing siding, or it's classification yard turnout 2, or you can give it different names. Again, just for simplicity here for this demo, we're just going to call it Servo 100. Okay. Now we're going to enter a couple more of these. We're going to try and be quick about this. We're going to call the next one ID at 101. It's going to be on pin 101. Active angle of say 350. Inactive or close angle of 400. This time we're going to give it a profile of fast, and give it a description of Servo 101. Okay, just jumping ahead slightly, I created my 4 servo turnout definitions. I did 4 just to be able to show the 4 profile speeds that you can use. And as you can see here, for defining your profile speed, you spell out the words instant, fast, medium, or slow with the first letter is uppercase. You can define as many servos as you want now. DCC EX will recognize the first 32 already defined in. That's 2 PCA 9685s. If you have more than that, you can add a third or fourth or etc. up to 62 PCA 9685s. But you have to tell DCC EX about them and configure them so that it recognizes them. And to do that, we need to go to our file browser and go to the file where you extracted your command station EX. And this is where it lists everything, all those tabs, everything that's part of the command station. And you will see in there, including the My Automation and the My Turnouts that we just created. But you'll also do this myhal.cpp example.txt. We want to actually create a copy of that. We're going to leave the original there just to keep it. So I don't want to open it, sorry. We're going to copy and just paste it back into this page. And so down here you see it creates a copy of that file. Now we want to rename that file. And we're just going to take away everything after CPP. So you have a myhal.cpp. When you hit enter, you're going to get this alert. Do you want to change the file extension because it was a .txt file? And yes, you do. Just hit enter, yes, and it creates this myhal.cpp. So now we can go back into the Arduino IDE. And you're going to need to just close this and reopen it so that it will find that new myhal.cpp file. So we're just going to reopen it real quick. Now when we come to this drop-down menu and we scroll down here, we can see it created that myhal.cpp. You can also see our My Automation and our My Turnouts. So click on the myhal.cpp and it brings up the file for adding the new controller. And there's some little description up here. It even says in the remarks up at the top, up to 2 PCA 9685 servo modules, that you don't need to modify this file. Well, since we want to add 3 or 4 or whatever the case may be, that's why we're modifying this file. That's why we've got it open. So you scroll down a little bit into this void house setup, and the first one there in this version is for the PCA 9685. This line here describes how to define the PCA 9685. So we're going to uncomment this line. The 2 dash or the 2 slashes comments out that line so it doesn't compile. So in their case here, their example, they're showing the first one they did, which has an address of 0x40, and it starts at pin number 100. So we know they have 2 defined, 100 through pin 131, which is 0x40 and 0x41. So you can define the next ones. We're going to want to define 0x42, and you tell it what the start pin is of this address, what you want to define as the start pin. So you could start at pin 200. In our case, we're just going to go to the next one in sequence, which is 132. This 16 tells it how many pins that there are. So since we know we're doing a 9685 with 16 pins, it will go from 132 through 147 inclusive. Okay, so that defines our first one. If you want to add more, you would just add another line for it. And I did a little bit of a shortcut here and already got one preloaded and ready to go. But in this case, we're just defining another PCA 9685, starting at pin 148, because 132 to the next 16 pins puts you at 147. The next pin is 148, 16 pins, and we're giving it the next address for the next PCA 9685 of 0x43. So we've created and identified, or created two more drivers for two more PCA 9685s. So that has everything defined that we need to upload our sketch to our Arduino to be able to control servo turnouts. If you didn't need to add these extra PCA 9685s, you would have just uploaded before this step. But we've got this done, so now the next step is to upload the sketch to our Arduino. So I'm just checking. I've got my COM ports picked. My Mega is the board that we're using. And then we just click on this arrow here, and hopefully we won't get any errors there. It says compiling. So this takes just a minute to compile. We'll watch for any errors that show up down here. Nope, it's done. So it's uploading it to the Arduino now. All right, it's done uploading. Everything is set and ready to go. So now we can actually move over to the Arduino and the PCA 9685s and some servos and try it out and see if it works. Okay, let's get this all together. Let's see if we can make these servos work. So what I've got here is I've got my 4 servos that we're trying to drive, my Arduino Mega that has the sketch uploaded to it that we're going to use as the command center. This is an ESP01 Wi-Fi module, so we can make our Wi-Fi connection. This is our PCA 9685 module for driving the servos. And this is just a typical standard motor shield that you would have to drive your tracks off of it. We've got our jumpers, and this is a 5 volt. This is a 3 amp power supply for powering our actual servos. Now I'm going to actually stack the Mega and the motor shield, but I'm going to stack it on a terminal board that I built, and I'll explain that more as I get it put together. But I'm going to get these pieces and kind of stack together so we're ready to go, and give me just a second. Okay, I got the boards I was telling you about stacked. Basically all it is I've got my Arduino with this header board stacked on top of it, and then my motor driver stacked on top of it. And all this board is, this header board is just that. It's header pins that I can screw into, so for long-term connections, it's a more secure, better connection. For this demonstration, I'm actually not going to use these header boards just because I don't have to mess with the screws. I'm just going to stick the pins into it. The only reason I'm using the board is that I've got a header on it for the Wi-Fi module. So I don't have to run extra wires. I'm just plugging it in and it's good to go. So what I've got is 2 wires for power. We've got a 5 volt and a ground connect, and then on the Mega pins 20 and 21 are the data and clock, the SDA and the SCL pins for your I2C communications. In this case, I know that I've got the yellow connected to the SCL and the green connected to the SDA pins. So we need to connect those to the module. I think, yeah, you can see you've got ground, SCL, SDA, VCC are the 4 pins that we're going to connect to. So we'll take our power jumpers. I know I've got the black to ground, and the white to the 5 volt, which is the VCC power in to the board. My yellow is the clock and my green is the data, so clock is SCL, that's the yellow. and then the SDA for the green. So that's our connections to the Arduino. Next we need to connect the servos, and so we're going to be using these first 4 pins, pin 100, 101, 102, and 103. And that's pretty easy. You just take your plug from the servo. The wires are color-coded. The brown, red, and orange correspond to the brown, red, and yellow on the board here. So you just plug it in to the corresponding header. And we'll plug in all 4 of them. Okay, so our connections are made there. The only thing left to do is connect the 5 volt for driving the servos here. I'm actually going to turn camera off for just a second to do that. So I'm going to make this 5 volt connection. Make sure you watch your polarity, but I'm going to make that connection and we'll get the next step. Okay, so we've got our connection made. We've got our 5 volt power supply for driving the servos connected to the PCA 9685. The Arduino is just plugged into the USB to provide its power so that it'll operate, and it should be ready to go. I'm using an Android device, so that means engine driver. So on my Android device I select my engine driver, and you can see it comes up with the discovered server. So connect to my server. Then you bring your engine selection. We're not doing any engines, any locos. So up here at the top you can see the 3 dots. So we'll just select on the 3 dots, and then Turnouts, and there they are. As we defined them, remember the Servo 100 through Servo 103 when we gave them a description. And as easy as you just push the button, and that's what throws and closes and throws the servos. So let's take a look at that. I think we'll start with this first servo here. This is the instant, and when we hit the button, you can see that it moves the servo. And it's a toggle back and forth between close and throw. Then on the second one, this is the difference of going from instant to fast. You can see it slows down quite a bit, although it is still moving and probably wouldn't be most realistic. Then we'll go to medium, which is the third servo, and you can see it slows it down a lot. It's pretty slow, and that's pretty good. And then the back servo back there is set on slow, so if we throw that one, you can see it really moves it slow. So there's your 4 profiles for the different servos from instant to slow. So the only thing left for you is, once you set this up and mount for controlling your turnouts, is to determine the positions for your throw and close. And if you remember, we set that up, the active and inactive positions on the servo definition is how you define that. And the only way to figure it out is to do some trial and error. You just have to set it up and do some trial and error with it to get it to the position you want. There is an app available that helps determine your settings for your servo, and it's called EX Toolbox. We'll make our connection. And what it does, it allows you to go into here, Servo Programmer, experiment with different settings on the servo. So the numbers here, 100 is the pin that you're driving, 205 is the close position, 307 is midpoint, and 409 is the throw position. You can change the profile, the speed that it closes and opens at by dropping down a window where you can select fast, medium, slow, instant. So just as a quick example, let's say we change the close position to 305. And then when we select the close and the throw, it changes the position. So it gives you a chance to experiment with. Then you have to make note of this number and then transfer that number over the IDE and upload it into the sketch. But this way you can experiment with different numbers without having to continuously keep trying a number, upload it, upload it, upload it, upload it. Wait till the end when you've got the numbers figured out and you can do it once. There's more to that. I know this toolbox than that. I'm not going to go into it any more depth than showing you that it is available and you can experiment with it to help find settings for your servo. So that's it. That's it for this tutorial. I hope it helps, and good luck getting your servo set up.